function is f of ABCD is equal to sigma m of 0, 4, 5, 6, 7, 9, 10, 12, 13 and 15. Calculate the number of prime implicants of the function. Option A 4, B 5, C 6 and D 7. So here the sum of minterms that are producing ones for this function ABCD Boolean variables is 0, 4, 5, 6, 7, 9, 10, 12, 13 and 15. So let us represent this with this K map. It is a 4 variable K map. We are having 16 different Boolean values in this. So this will be the K map here. So we take 4 variables like this. So this is A, B, C, D. These are the Boolean variables given. 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 1. So the minterms producing ones are, that is 0. This is 0, 1, 2, 3. Again 4, 5, 6, 7. Again 8, 9, 10 and 11. 11 is not producing one. Again 12, 13, 14 and 15. So these are the minterms that are producing ones. So we can combine the maximum possibilities of these mappings in this K map. So this is one mapping, this is one prime implicant, and we can map these four. This is another prime implicant, this is a second one, and we can map these four. This is another implicant, this is the third one. Okay, next this is a separate, only single one will be mapped. This is fourth one, and this is fifth, and this is sixth. Total 6 prime implicants are there. We can have this Boolean term also for this. So the first one for this, it will be A dash B, that is one minterm. The other is BD. This is another minterm. BD is there. A dash B is there. And again this one, if you take this one, we will get BC dash. BC dash is another term which is a prime implicant, and this one is AC dash D. AC dash D, and this one is A dash C dash and D dash, and this one is A B dash C D dash. So these are the 6 items that are the prime implicants. So A dash B, BD is there, and then BC dash, again AC dash D, again A dash C dash D dash, again A B dash C D dash. So these are the implicants. So there are total 6 prime implicants, so it will be 6. Option C is the right option here. Given memory is as follows. So memory is given like this in the diagram. Suppose we have the instruction LDA 500. LDA loads content of memory location to accumulator AC. What would be loaded into the AC if the addressing mode for the operand is direct and indirect respectively? So here we have got one instruction, that is LDA 500. Usually LDA instruction is meant for content of memory at address indicated by the address part of instruction will be loaded into the accumulator register, where accumulator register is mentioned as AC here. So what will be loaded into AC when this instruction is executed using a direct addressing mode and a indirect addressing mode? By using these two types of addressing modes, finally what will be the content of AC? What will be loaded into AC? Usually in the case of direct addressing mode, the address part of instruction is the effective address. In the case of indirect addressing mode, the address part of instruction is a pointer to the effective address. So here now the address part of instruction is 500 and the opcode part is LDA. LDA is in an operation code that will load the content of memory location that is indicated by the address part into the AC register. So now if the effective address is 500, for example, the content of memory at address 500 is 600. So that is, in the case of direct addressing mode, the 600 will be loaded into AC register because the effective address is 500. In the case of indirect, here the address part is 500, so m of 500 will be the effective address here. What is m of 500? 600. Okay, now m of 600 here is content of memory at address 600 will be 700. So 700 loaded will be AC, that is content of memory at address 600 will be loaded into AC register, so that 700 will be the content of AC after execution of the instruction if the addressing mode is indirect. So for direct it is 600, for indirect it is 700. So option B is the right option here, 600 and 700 respectively. Which of the following is not true regarding the service provided by TCP? Option A, TCP guarantees delivery of all data. Option B, TCP service is connection oriented. Option C, TCP guarantees that a sending process is permitted to transmit data at any rate. Option D, TCP does not provide any delay guarantee, that is how long the data may take to get to the destination. So these are the four options given. We need to find out the statement which is not true. So let us see one by one. Option A, TCP guarantees delivery of all data. This is a true statement because TCP is a transmission control protocol which is in the transport layer. It is a connection oriented protocol and a delivery guarantee of data will be there in the TCP. UDP is no guarantee of delivery. Now the statement 2, TCP service is connection oriented. In a transport we are having two types of protocols. One is a TCP protocol, other is UDP protocol. TCP is the connection oriented protocol and UDP is the connectionless protocol. So that option B is also true statement. We need the false statement, the statement which is not true. TCP guarantees that a sending process is permitted to transmit data at any rate. Actually the rate of transmission of data is not in the hand of TCP because it has to use the underlying IP protocol, so that is not giving any guarantee of the delivery of data, that is the rate of the transmission of data, so that TCP will not give any guarantee. So that option C is the right option because it is the false statement. Option D, TCP does not provide any delay guarantee, that is how long the data may take to get to the destination. Delay guarantee also will not be given by the TCP. This is the true statement. So option C is the right option here.
A connected graph that has p vertices and p-1 edges. First option is cannot contain a cycle. Second option, option B, must contain at least one cycle. Option C, can contain at most two cycles. And option D, none of these. Here it is given that graph contains p vertices and exactly p-1 edges. Let us take p as 2. So number of vertices are 2 and p-1 edges, 2 minus 1, that means 1 edge. So here 1 edge. In this graph doesn't contain any cycle. Let us take p as p is equal to 2 here. Let us take p is equal to 3 and the graph should contain p-1 edges. So here when p is equal to 3, number of edges should be 2. Either this one or we can take this one. Like we can also take this one. This is just like spanning tree with n vertices. In a spanning tree with n vertices, there should be exactly n-1 edges, and in a spanning tree there won't be any cycles. So here correct option is option A, which states that cannot contain a cycle. So here correct option is option A.